VLSos here. This is a video lesson on a power property, product of powers. Product means multiply. And what we mean by a power property in this case is when we're multiplying two powers, there's a fast way to simplify. For example, we could have the power x to the fourth. That's a power with base x and the exponent of 4. And if we're multiplying by a power with the same base, in this case x to the third, then we can simplify this product of these powers. There is a longer way to reason how to simplify by being reminded that a power is repeated multiplication. So x to the fourth means multiply x, the base, by itself 4 times. X to the fourth means x times x times x times x. And if we're multiplying by x to the third, then we can think of this power, x to the third, as x times itself 3 times. X times x times x. So here we've represented the expansions of these powers. And if what we're doing with these two is multiplying them, then all of these x's are multiplying itself, and we can think of these 7 x's now as a power, x to the 7th. This was a long way of reasoning it. We simply expanded the powers, saw that we were multiplying x 7 times, and then put it back into power form to get the simplified answer. We can do this a quicker way with a power property. And the power property is this in general terms. If you have a power with any base b and exponent n, and you're multiplying by a power with the same base b and a different exponent m, then you can simplify this into a power with, again, that same base b by adding the exponents. I'm going to put a box around this because it's always true that this will work as long as you begin with two powers that you're multiplying with the same bases. You can simplify it into a single power by adding the exponents. In this case, we have two powers with the same base x. So we can think of this as a power with the same base and add the exponents 4 and 3 to end up with x to the 7th, just like we did before. This power property can be used to really speed things up. For example, 3 times x to the 20th times 4x to the 50. Here we have two powers, but the powers are also multiplying two numbers. The 3 and the 4 are going to multiply each other, and we can rearrange what we're multiplying so that we can see the power x to the 20th times x to the 50th separated from the 3 and the 4. The 3 and the 4 still make 12. But how do I simplify these two powers with the same base x that are multiplying each other? Well, I can express it as 1 power to the exponent as the sum of the two exponents 20 and 50. And in a final simplified step, this will be 12x to the 70th. imagine doing this part of this problem, thinking of it as an expansion. We'd have to write x 20 times and then multiply, writing x 50 more times. So using this property was very fast. One more example. X squared times y cubed. This is a product. We have two powers, x to the second and y to the third. How do we simplify this? We can't use this property because this property requires the bases of the powers to be the same. These two powers have different bases. One is x, one is y. So we cannot use the property. We can't combine these powers. We can't simplify it anymore. We could say it's already simplified. And why can't we go any further? The bases are not equal. So we can't apply the property that requires them to be.